And okay, this is Zhen Fengzhen, and I'm going to do the homework 2 for the 2 question. And this is the second question for the probability and the schematic process. Okay, let's begin. And in this problem, we have this function. This is a density function. We see that x equals to 0, and we have this one. If x in the middle of 0 and 1, we have this one, and otherwise it is 0. And the first problem is that we need to find in A, make that density function valid. So you see that this is a density function. So we can use the integral of this function. It is a probability. So if it is a probability, so we must have this equation like the integral of this function must to be 1. And so we're gonna figure out this function. And we have a e minus 2. And if we integral this third x, we have is u x here, x equals 0. And plus integral from 0 to 1 e minus 1 ex plus e minus x dx. This equals to 1. So we're gonna figure out this function is this one equals to a e minus 2, because when x is equals to 0 and the ux equals to 1 plus e minus 1 with ex from 0 to 1 minus e full x from 0 to 1. And this one equals to 1. So we have a e minus 2 plus e minus 1 multiply with e minus 1 minus e minus 1 plus 1 equals to 1. So we cancel this to 1. And what we have is a e minus 2 plus, and this equals to this one equals to 1 minus e minus 2 equals to 1. So we have a equals to 1. Okay, this is the first problem. And in the second problem, we need to sketch what is the density function. We need to sketch fxx. And firstly, we have to determine whether this function is monotone increasing function. And so we have dfxx and dx equals to ex minus this e minus x. And we see this function is like this, and this function is like this. But x is in the middle of 0 and 1. So dfx x and dx is more than 0. So this function is monotone increasing function. And by using the MATLAB, and we have this function is like this is the first part, and the number of it is 2 multiplied with e minus 1, and okay, and then this part, when it is 1, it is like 1 plus e minus 2. And by using the MATLAB, and we have already known that this function is increasing function, monotone increasing. So, and the result is like this. Okay. And the third problem, we need to use single equation to rewrite what is the density function fxx. And we have fx x equals to, okay, we know that a equals to 0, if a equals to 1, so we have fx equals to e minus 2 third x, sorry, e minus 2 third x plus e minus 1 e x plus e minus x, and multiply with u x minus u x minus 1. Okay, because this one, it means x from 0 to 1. Why? Because this is ux and this is ux minus 1. So this one means like this, 0 to 1. And otherwise it is always 0. Okay. Sorry, I got to erase something. Wait a minute. Okay. And in the first question, we need to figure out what is this line like. Okay, we all know that this kind of function is the integral of the density function. So it equals to unlimited minus unlimited to y by fxx and dx, the integration. So we're gonna figure out when y is minus 0, we have y equals to 0. When y equals to 0, we have y equals to this one, e minus 2 mu x, because the delta x, the integral of delta x equals to ux. So, sorry, here's y. And when y is equals to 0, this one equals to e minus 2. And when y is the middle of 0 and 1, we have y, we must equal this one. We must, plus this one equals to e minus 2 plus the integral of e minus 1 ex minus e minus x dx. Okay, I'm gonna make a simple equation for this one. It is equals to e minus 2 plus e y minus 1 minus e minus y minus 1. Okay, and for y more than 1, we're gonna put y equals to 1 into this equation. So we have y equals to e minus 2 plus e 1 minus 1 minus e minus 1 minus 1. This one equals to 1. So the totally y equals to 0 for y minus 0, and e minus 2 for y equals to 0, and e minus 2 plus the y minus 1 minus e minus y minus 1 for y in the middle of 0 and 1, and 1 for y more than 1. So this is the analytical equation for IYY. Okay, sorry. And the last problem, we have to sketch what is FYY. Okay, and we use that analytical equation, analytical function, and we have, okay, and we see this one is also monotone increasing function, and by using the MATLAB, and we can figure out the FYY, equals to when y is minus 0 and it is all 0, and y is, when y is equals to 0, this one equals to here e minus 2, and when it's more than 0, this one equals to 1 e minus 0, and when y is limited to 1, and this one is nearly to be 1. Okay. And what we have is like this. And when y is more than 1, and FYY is always be 1. So that's all. Thank you.